2005. Then I looked at the expertise and how we distribute energy. And so that's the electric grid. And you have to look at the grid as a system and look at the devices within the grid and just how you implement. Again, the grid is an aging infrastructure, but when you introduce new technologies into the grid, you have to really be careful on how the integration works or doesn't. Okay? And then you have a cyber layer on it that we now have to look at. We also categorize energy in terms of how we use it. So again, energy efficient buildings, whether it's a new building or an old building, how do you integrate new technologies into an old building and make it energy efficient? We also need to look at advanced engine designs. And there's a lot of research going on here at Texas A&M in chemical engineering and mechanical engineering and aerospace engineering. And I think in engineering technology, looking at advanced engines. And then looking at the transportation infrastructure as a whole, the whole system. Then, what about systems engineering? That's huge. Integrating all the pieces together and doing a risk analysis on it. And safety. And then how can you influence energy policy? Big questions. Now, just this slide and the next one is just an inventory of the existing centers and institutes that we have in the engineering program that are related to energy. And you can see the breadth and depth that we have here. So just in oil and gas, we've been doing that for a long time, and we're well known in our expertise. The nuclear program, most universities have shut down their research reactors. We didn't, and our department is growing rapidly. We're talking about setting up a natural gas center, and I think this is going to be huge for the future, like the immediate future. In bioenergy, we have a formal alliance with our agriculture program, and I'll talk about just a second. The turbo machinery laboratory under wind, it wasn't set up to support wind energy, but it's an opportunity to look at their expertise over there for wind turbines. So I've talked to Dr. Derek Childs, who is a faculty member in this department. Huge facility. If you haven't seen it, try to take a tour of it. It's by an airport. We have a new wind energy center that was approved in March. And I just hired a new director in August. And so he's already very busy working with faculty and students and industry. His position is funded by Vestas Wind Systems out of Denmark. And so we're working with them very closely. A unique feature with Texas A&M Engineering is our safety program. And this is something that I'm really going to develop across all the energy sectors. If you look at other university websites on energy, they basically focus on the renewable sources like solar and maybe some bioenergy, etc. But not too many will talk about safety. And that obviously with BP, that's huge. It's a very quantitative, analytical approach to safety. It's a very powerful center. The director is based on chemical engineering. We have two NSF centers. One is in materials, the International Materials Institute, IMI. The director is out of aerospace engineering, but works with faculty across several departments. And then the Plug-in Electric Vehicle Center that's from MIT, both of those just got funded within the last year. Architecture Center is listed up there for energy efficiency. We're working with the Bristol and their Policy Institute. So we've got a lot here. How do we pull everybody together and share a vision in making an impact on energy? This is going to be tough to read, but again, taking that slide I had with feedstock, energy conversion, distribution, energy in use, and systems, it's an attempt to categorize this in this org chart. This is the institute. So the yellow arrow is where I am. And I'm trying to get faculty in all of these areas to play well in the sandbox. It's really fun. Like I said, I just hired a wind director. He's from the University of Texas, but I converted him. And he is really, really busy already. I was on the phone with him as I was driving in here on some stuff. But the cross-disciplinary areas are absolutely critical. And I'm going to have to reconfigure this whole chart to embrace the cross-disciplinary area. Materials, how many of you are doing materials work? Okay. Anybody doing solar cells or wind blades, or what are you doing? Okay. Well, materials is huge across all the sectors, even in oil and gas. If I ask my petroleum engineering department head what critical advances are needed in the oil and gas industry, we've had a discussion about this. If you look at drill bits, there's work going on in developing nanostructured materials that are very robust and can weather the harsh environments underground. And so to coat these drill bits with a robust material that could be designed at the nanoscale, that's something that's not covered in the petroleum engineering department, but it could be covered in this department. Okay, so that's just an example. Systems engineering, again, I cannot overemphasize how important that is. Risk analysis, etc. So all of these areas are very important. Now the philosophy I want to take with the Energy Engineering Institute at systems level. What you're going to do as students, typically, is work in this space. You're going to develop some sort of technology, some sort of material, maybe a process that may be related to a feedstock or a bioconversion process or some sort of energy conversion, or how we use it. But if you integrate your technology or process into a system, it may not perform as you had designed for it to. So it's the unintended consequences that would arise technically by looking at a systems approach. Now, industry loves this because they work with universities that, with a very narrow point of view of their work. But the question is, how can they use it and make a profit? They need to look at it in this manner. We have boundary conditions, however. We have regulatory issues, policy, constraint, and then again, if you develop something and nobody wants it, what good is it? So in the Institute, we'd like to address this holistic energy systems approach. Going down to the weeds a little bit, advanced energy technologies. This is an article in Small Times Magazine published in 2005. But discussion for years on how to develop nanostructured materials for solar cells, batteries, etc., how to integrate computer science, and so on and so forth. So just be aware that if you're in the nanotechnology area, there's a huge contribution you can make in the energy space. Cybersecurity. You would not believe the companies calling me about cybersecurity. Companies you wouldn't, well, I'll categorize them. They're in the aerospace industry. Why would aerospace care about this? So we're having a very interesting conversation. This is a complex interdependency. To put a cyber layer on a physical infrastructure that, in general, is aging, but you start integrating renewable sources of energy with traditional sources of energy on the grid for residential, industrial, commercial applications, and how you design this cyber layer to protect the system from terrorist attacks, blackouts, etc. It's not very simple. You've heard of smart meter. If you insert smart meters, integrate them into like a residential area, integrate that with the grid, it's not secure from cyber attacks. And it can tell you how much energy you're using. So if you talk to a smart meter company, they're going to avoid the question. But unintended consequences, so this is something to look at. Okay. How much time do I have? 10 minutes? Okay. 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 Let me rush through this. Dr. Anomaly is part of this. Raise your hand. Let me just give you this example about an energy system. Lots of different feedstock options to look at. Does anybody know what the feedstock is here with all this cattle?
Cow manure. Cow manure.
Yeah, there's a lot of it here.